Hello everyone, welcome to my channel. ನನ್ನ ಚಾನಲ್ಗೆ ಎಲ್ರಿಗೂ ಸ್ವಾಗತ. In my previous video, we discussed regarding the physics topics for Gpstr. That is, we were discussing on measurements, units, fundamental units, and derived units. In this video, friends, we will be discussing about natural forces, forces that are naturally available in our environment. Before going in details, friends, if you have still not subscribed to my channel, please do subscribe. And to get updates on my upcoming videos, please click on bell icon and share the videos. I shall be creating many videos on GPSTR topics, especially on science. So to go through all those videos, please do subscribe to my channel. Let us quickly glance over the for today's topic. Uh, in this class, I will be discussing on the four fundamental forces and their strengths. See, basically, let us try to understand meaning of force. What is a force? How do you relate that force with an object? Force is a push or pull action that can be done on any object. That means we can push or we can pull any object if we apply force on it. That means we can, force is nothing but an energy that causes motion in an object. Because of the force, the direction of the object can be changed, the velocity of the object can be changed. So it is basically an energy that we are applying so that the velocity and the direction of the object can be changed or taken or differentiated. That means by applying the energy on that particular object, we can cause the object to move from one direction to other direction. That means we can pull the object with the help of force, we can push the object with the help of force. That is why we define force as push or pull action that can be caused over an object. This is basically force. In nature, we have naturally available forces, four fundamental forces that we have: gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. Let us first quickly see what is gravitational force. Friends, it is because we are able to walk freely on the ground. It is because of the force of gravity. It is because we are able to stick something on the wall. It is adhesive force. The force or a gravitational force is an attractive force, the force that exists between any two objects in an universe. This gravitational force is always attractive. It is because of the gravitational force that we are comfortably able to walk, or any ball falling from top it directly, or any fruit falling from a tree, it comes down, it doesn't go up. It is because of the gravity of the earth, the gravitational force of the earth. So any vehicle moves comfortably on the ground, it is because of the gravitational force that is holding or that is pulling the vehicles on the ground. It is gravitational force. So if you go here, gravitational force is a weak force but very long ranged. See, gravitational force is a weak force. That means this is weak because it covers a very long distances. So there is a gravitational force. See, the force between moon and earth, there exists a force between moon and earth. It is gravitational force, but the force is weak. So as the distance between two objects increase, the magnitude of the amount of force decreases. So this gravitational force exists between two objects, but the distance between the objects can vary from a very small distance to a very long distance. So the gravitation force is weak. Furthermore, it is always attractive. That means the gravitational force, because of the gravitational force, two objects are always tending to come together, they are always tending to move towards each other, it is because of the gravitational force. The force that is applied among those, that means the force that exists between those two objects is gravitational force. That is the reason two objects always tend to move towards each other. It acts between any two pieces of matter in the universe since mass is the its source. The gravitational force exists between any object, it is because of the mass of the object. The mass of the object causes this force. That is why the fundamental uh, unit of gravitational force is mass. So, hope you understood one of the fundamental natural forces, that is gravitational force. Let us quickly go on to weak nuclear force. Weak nuclear force. Let me try to read it once and explain you what is weak nuclear force. The weak force is responsible for radioactive decay and neutrino interactions. That means there is a decay of radioactive neutrons. It has very short range. The distance between that means the force is not active, that the force is not very strong beyond some distance. It is active in a very small range of distance. As its name indicates, it's very weak. This is very weak force, it is not strong force. The weak force causes a beta decay, that is the conversion of neutrino into a proton, an electron, and a antineutrino. That means in nuclear objects this force exists and this force is very weak. So this is one of the four natural forces that is available, that is weak nuclear force. Then we can see electromagnetic force. The third one is electromagnetic force. Let us try to understand electric field and magnetic field. Any object having charge carries the magnetic field. Any object having any type of charge, maybe it is a positive charge or a negative charge, it carries a either electromagnetic field or either carries a magnetic field or electric field. The electric field is in the sense the field is strong if there are more number of charges on the object. The field, maybe electric field or magnetic field, is weak if there are less number of charges on the object. So any object that has a charges has a magnetic or electric field around it. So let us maybe there is a confusion like which object has electric field and which object has magnetic field. A object which are which has charges on it and which is moving has magnetic field. Object which are charges on it and which is still in position, that means which is not moving but has charges, will carry electric field. So this is what is the difference between electric field and magnetic field. So object carrying both the fields is electromagnetic field. Because of the electromagnetic field, because of the electromagnetic field, an object carries an electromagnetic field. Because of this, it it attracts few objects, it repels few objects. Let us see quickly what is electromagnetic force. The electromagnetic force causes electric and magnetic effects such as the repulsion between like electrical charges or interaction of bar magnets. That means, see, we have studied a rule called like poles or like charges repel each other, unlike charges attract each other. This attraction and repulsion is because of the electromagnetic fields that is created around the objects which are having charges. It is long ranged but weaker than the strong force. This is long range force. That means the electromagnetic field goes up to some distance around the object. As the distance between the object and the field increases, the strength of the field decreases. As the distance increases, the strength of electromagnetic field decreases. That means, let me show you here. Like this is an object here. This is an object here, and it has charges, something like this. It has charges like this. So I say this is electric field. So this is electric field around the object. So as the distance between this object and the field goes beyond some distance, then this electric field becomes zero. So the strength of the field here is stronger than the strength of the field here. So at this point, the weak is the electric field is weak, and at this point, the electric field is stronger because it is nearer to the object, and the amount of charges will be more, and hence the field is stronger at the object. And as the field moves away from the object, the electric field becomes weak. Likewise, magnetic field as well. So long ranged but weaker than the strong force, it can be attractive or repulsive, and acts only between pieces of matter carrying electrical charge. That means the electromagnetic field acts among those objects which carry only the electrical charges. So this is a concept behind electromagnetic force. Let us see what is the last force, that is strong nuclear force. Let us try to understand what is a strong nuclear force. Basically, we have seen an atom. In an atom, let me try to draw an atom here. In an atom, there is a nucleus. In a nucleus, we have neutrons and protons, and around this nucleus, electrons revolve. So this is what we know about atom. This is a nucleus. This is protons and neutrons. There are a number of protons and number of neutrons, and electrons revolve around the nucleus. And let me separately draw nucleus here. There is one proton here, there is one neutron here, there is again a proton here, there is a neutron here. See, what is strong nuclear force? Strong nuclear force is the force that is existing between proton and neutron in a nucleus. The force that is existing between proton and neutron in a nucleus is very strong. Since the force is very strong, they are not able to come out of the nucleus. They are held tightly together. Though the distance is very small, but it is a small range force but very strong force. It is very difficult to separate proton and neutron. The strong interaction is very, the strong interaction is very strong but very short ranged. See, distance is very small but it is very short range but very strong force. It is responsible for holding the nuclei of atoms together. Nuclei of atoms together in the sense, see, proton and neutron becomes a nucleus. There are number of nuclei in an atom or in a matter. So these nuclei are held together. It is because of the strong nuclear force. That means there is a strong attraction force between proton and neutrons. Hence, they are held together. It is basically attractive but can effectively repulse you in some circumstances. The strong force is carried by particles called gluons. This strong force, what is the reason? What is the factor this force is very strong? These are the small particles called gluons. These gluons are responsible for this strong force. When two particles interact through a strong force, they do by exchanging gluons. See, that means when two particles are interacting through a strong force, that means they are exchanging gluons. Thus, quarks inside the protons and neutrons are bound together by the exchange of strong nuclear force. That means protons and neutrons are held together by the exchange of protons and neutrons. While they are close together, the quarks experience a little force. While they are close together, the quarks experience little force, but as they separate, the force between them grows rapidly, pulling them back together. See, this is how, see, as they separate, the force between them increases and they pull each other and they are held together. To separate two quarks completely would require far more energy than any possible particle accelerator could provide. That means, why do we call this force as strong force? Because if you want to separate those two, that is protons and neutrons, we require a very strong force to separate those particles. That is why we call it as a very strong force. So friends, in this video we have seen four fundamental or natural forces in nature that are available, that is gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. So basically this these four a list of these four forces is very important for as per as your Gpstr is considered, or as per your Ctet is considered, or KRTET is considered. So hope you understood something about fundamental forces that are present in nature. Friends, if you like this video, please do subscribe to my channel and click on bell icon for more updates. I shall be creating more videos on your GPSTR or your Ctet syllabus. So please subscribe to my channel and click on bell icon. Thank you and all for watching this video.